Hi guys, let's work this problem really quickly here and for an example for you to look at later if you need to. So suppose the polar bear were running on land instead of swimming. The polar bear runs at a speed of 8.3 meters per second. How far will it travel in 10 hours? So if we start off with our givens, we have a speed or velocity of 8.3 meters per second. Okay, and then we have a time of 10.0 hours. All right, and so we can see right off here, one of the things you want to pay attention to is, do your units match? So we can see right here that our hours and our seconds don't match. So we need to make hours match seconds. So somewhere on your paper you want to work that. We'll just work it right here underneath it. So that would be 10.0 hours. And we multiply by a ratio, and where hours is on bottom, seconds are on top, and 1 hour is 3,600 seconds. So we know that ratio, 1 hour is 3,600 seconds. And so 36,000 seconds would be the time we use. So now that we've converted our units, our givens are 8.3 and 36,000. All right, so now we need an equation. And this equation for this section is velocity is the displacement or change in distance over change in time. So if you remember, delta x is displacement. All right, and so we want to know how far, so that's our delta x. So to solve this equation for delta x, we're going to cross multiply. All right, and so that gives us the change in time times the velocity of the object is equal to the change in distance or displacement of the, in this case, the bear. So at this point, we just plug in our numbers. Delta t is 3,600 seconds times our change in velocity, 8.3. That's a meter per second, equals our change in x. Okay. All right, guys, so we want to divide this out, or excuse me, not divide, multiply to get the answer. So we get 3,600 times 8.3, and we get 298,800, and that would be a meter. All right, so now the problem is we need to report this in the correct number of significant figures. So we go to our problem and we see two significant figures. All right, we find our other given over here, 10.0, and we find that's three significant figures. Sorry for the handwriting there. And so that means our answer can only have two significant figures. Well, the problem with this number and two significant figures is you're going to have to report it in scientific notation. So here is our first, and there is our second significant figure. So the 8 would round. So 298,000 meters rounds to 300,000 meters. Okay, that's still not two significant figures. So for two significant figures, we must write it in scientific notation. So we move the decimal once, twice, 3 times, 4 times, 5 times. And when we finalize the scientific notation, we have the 0, and that gives us two significant figures. So our final answer, correctly reported to significant figures, 3.0 times 10 to the 5 meters.